In this tutorial, we will be completing the data analysis for Scientific Writing 4. So to begin, you're going to download this file. This file might seem a little enticing at first. It's quite large. It's actually bigger than the body composition Excel, except we use a rapid fire entry that will make it a lot simpler and kind of cut down on what might seem scary. So to begin, you see that the data sheet is full of a lot of zeros. This is going to auto-populate similar to other files we've used throughout the semester. Then, depending on your class size, will change the number of subjects. This one I only have 15 subjects. You might have double this, depending all of the labs combined. So to begin, I'll go into subject 1, and I'm going to hold down the shift or shift command and select all my subjects. If you have more subjects than you can reach, you might have to do this in 2 bouts, but a copy and paste should work pretty well to do so. So first things first, I need to calculate VO2 in absolute term, kcals per minute, and then to get area kcals. So you can see that process in your lab manual on page 93. So to start, we're going to take the VO2 in relative form, multiply by weight, and we want to hold that weight there, so we need to hold that exact cell. So we'll put a money sign before both the B and the 3, and then divide by 1,000. For kcals, we're going to take that and multiply by 5. And then for 0, this is actually our basal metabolic rate that we see up here. This auto-populates, same with heart rate. If I look here, it's taking from the resting heart rate up there. And it's just to get a better graph. So for the area, we're not going to put anything there. I'm just going to black that out. And I'm going to drag this all the way down. And I'm going to copy and paste this exact same thing here. If I double click, you'll see that we're still taking this, and that weight is staying the same. This area we can block off too, and then we can actually go calculate area. So if you look here, area in kcals is change in time multiplied by kcals per minute. So our change in time, we took readings every 30 seconds or 0.5 minutes. So I'm going to multiply kcals per minute by 0.5 minutes. Drag on down. And do the same thing over here. So now we can go in and start calculating all the stuff we actually need to. So if we go down to our data analysis, we're taking the average and standard deviation of our RER, which we've done plenty of times, and you're going to take the average of all the values, including the resting. We're going to find the max value in our VO2 relative form, so right above it. And then we're looking for our gross kcals during exercise. So we're going to sum, and then we actually need to make sure we're in the right column. So over an area, and I accidentally selected one too many. And to find net kcals, if I scroll back up, here we see that the net kcals is going to be our gross kcals minus our change in time. So for traditional training, we see it's 10 minutes multiplied by our kcals per minute, so that top box. And then we're going to do the same thing for our kcals during epoch. So everything under this line, make sure again you're in the area for /kcals column. And then our change in time is going to be 5. So now we do the same process over here. You can't just copy and paste for this one because of the difference in time. This time it's 8 for our change in time. But epoch is still 5. Okay, so if I go back into my data sheet, we can see that all looks right. All these values seem very reasonable. There isn't anything that's drastically outstanding. So now we can run our true data analysis. And we've done t-test before. Same process. T.test, array 1, array 2, 2 tails, and comma 1. Then we're looking for averages. Make sure you don't include the t-test. And we have all that data. So here our statistical significance, similar to before, it just has to be less than 0.05. All of these values are, so all of these values are significant. Now for your results, you need to create a table with all of these values. So it's just a matter of going in, reorganizing these however you see best. This is one example. It doesn't have to look exactly like this, but they should all be on the same graph so you can see what those p-values are in comparison to what the actual average and standard deviation is for each. Then you have to create a scatter plot of one person during traditional and one person during interval training, and this should include epoch. To do this, you're just going to pick any subject, go in, and I'm going to take these two columns, and insert a scatter plot. Then you'd go in and enter our typical data. delete any white space as necessary. There's not a ton in this graph. And then you are going to have to add lines to it. So the first line is going to go across and be even with your line for basal metabolic rate. And then you're also going to create a line where we see, or where we stopped exercise. So this changes between traditional training and interval training. And you define that in your figure description. And then you look at the trend we see when we compare the two. You'll do the exact same thing, but you're just going to use the interval training data instead. And you can, when you go to move this into your file, your document, you're either going to need to do these lines in that document, or what I suggest is easiest is if you search snipping tool on your computer, you can just take a snip, Control C or Command Control C to get that picture in. And that's what this is in your lab manual. That's how I got that there. And that is how you complete the Excel portion and data analysis and results for Scientific Writing 4.